If you've been developing on MapleStory Worlds, you've likely come across callback functions. Today, we're going to talk about what these are, how they're used, and what situations you'll often see them in. First, let's give a bit of context to situations where we need these callbacks. We'll quickly recap async versus sync for our example before we jump in. If you haven't already though, I recommend you check out that video before you continue with this one. There will be a link in the description. You're responsible for chores today. You have to clean the floor, the dishes, and the laundry. Let's take a look at this timeline. You'll have to complete each task before you can move on to the next one. The floor takes 10 minutes, the dishes 30, and the laundry 50. This is our synchronous system. We wait for the previous task to finish before we move on to the next one. That's all one person can do, right? Well, maybe not. Let's consider if we had a washing machine. Does it make sense to wait on the laundry when we could turn on the machine at the beginning and just let it run? We can turn on the washing machine and then work on other chores to make better use of our time. Take a look at this image. This is a good example of an asynchronous system. Now we can better introduce the idea of what a callback is. Unfortunately, when our washing machine finishes, there's still more to do with our laundry. We want to put it in a dryer and later fold the clothes, but we don't know exactly when our clothes are going to be done washing. This is where our callback will come into play. This is the task that we want to perform after the task we let run in the background is complete. This will become more clear once we look at how it's used in code. Let's start our dive into how this is important with mLua. One of the most common situations you'll see while building your world is getting and saving data in data storage. If you've looked at this before, you'll have noticed that there are both synchronous and asynchronous ways of pulling data in mLua. For example, let's say we have a global data storage, and we want to save some data in there. mLua actually gives us two options. We can choose to set and wait, which will halt the progress of the current logic until it's finished saving that data, or we can choose set async, which will let us save the data in its own time and continue the next step in logic immediately. Now let's go back to what we talked about with the callback. You'll see that the setAsync function has a parameter for another function, and we can't print the error code or success code if we aren't even sure it's finished trying to save. So we could use this function to serve as our next step in logic after the data storage has finished trying to save. So in general, the callback function is just a normal function that is going to get called when the async function decides it's ready to. Here's an example of what that looks like. Generally, callback functions are going to require different parameters depending on what's calling it. For the data storage callback example, you'll need two specific parameters, error code and key. Other than that, there is nothing special about the function. It can do whatever you would like it to. You'll see it takes an error code and a key as a parameter, then just prints the error or success. Now going back to the setAsync code for a minute, we can see the whole picture. Another heavy application you'll see using callbacks is when we're working with our UI. If you started already working with events, such as button click event, you'll realize that events are actually a way of managing callbacks. Consider the following code for a moment. This connect event function on all service components ties our callback function to execute when the event is triggered. This is a bit of a bonus feature I'd like to cover. When building your game, you'll often want things that run off of a timer. You can do this with logic in the update call like so. This example simply rotates the current object a small amount like a clock every second. But it's a bit repetitive to set up for every timer you need. In this example, the timer is repeating, but this is especially a big problem with single-use timers. Luckily, MapleStory Worlds has a built-in service to help mitigate that. Let's take a look at how we can refactor the above code with our timer service. This function performs the same logic as our first code block. It uses our timer service to schedule an action from the callback function and repeats that action every second. This simplifies the code a lot and removes bloat from our performance-sensitive update functions. If we wanted to perform an action a single time, we could additionally use the setTimerOnce function. And we're able to stop a timer at any time as well with the clearTimer function. This functionality might go under the radar for some people coming from Unity, so I hope you check this out. That's everything for this video. I hope you've learned a bit more about MapleStory Worlds and more ways to better implement your game logic. Thanks for watching.